Okay, on number 10, it says write each equation in its equivalent exponential form. Guys, be careful that you don't try and solve these equations. They're not asking you to solve anything. They're just asking you to rewrite. So it's a log right now. The base is 2, so I'm going to raise both sides as a power of 2. And I get 32 equals 2 to the 5th. That is the answer. Okay? Here, natural log. What's the base of a natural log? E. That is log base E. So we raise both sides to the power of E. And you get 1 equals E to the 0 power. And that's my answer. Here the base is B. B raised to the, so final answer 125 equals B to the 5th, or B to the 5th equals 125. Cool. On 11 is the exact opposite. Go from exponential to log. Well, the exponential base is 3, so we're going to take log base 3 of both sides. So this is log base 3 of 3 to the 4th equals log base 3 of 81. These simplify out. Final answer, 4 equals log base 3 of 81. Okay? This one is not an obvious exponential expression. You got to rewrite it. This is 8 to the 1/3 power equals 2. Square root is 1/2, a cubed root is 1/3, blah, blah. It means the exponential base is 8. So we're going to take log base 8 of both sides. Log base 8 of 2. These cancel each other out. 1/3 equals log base 8 of 2. And that's my answer. For this one, the base is b, so if I take log base b of both sides, log base b, they simplify out. Final answer, negative 2 equals log base b of 0.01. And there we go. Graphing logarithms, again, we're just going to be using our calculator. So, y equals, I need to type in log base 3 of x plus 2. So, a couple different ways to do that. You could do change the base formula, but since we have this, we'll go ahead and do alpha window and do log base. Log base 3 of x plus 2. Go to the table. At -1 at 0. At 0 it's 0.63. At 1 it's 1. And then it's 1.2. And then a 1.5. And then 1.6. And then 1.7. And then at 7 it's 2. And then at 10 it's 2.26. So that kind of gives me a goal. Alright. Now, guys, I had a lot of people. I'm talking to all y'all. I had a lot of people mess up graphing a log on their test. You've got to know what a logarithm looks like. And you can, you have a graph in front of you, but even so, this doesn't show you everything. You just have to know that a log is the inverse of the exponential, right? So if an exponential does this, then a log does this. I had so many people have a starting point, and that's all they drew. And then I had people draw a horizontal asymptote with that. It doesn't have a horizontal asymptote. Logarithms have a what? They have a vertical asymptote, okay? No excuse for sketching a logarithm wrong. We've done it over and over and over, and you should know what that looks like. Now, as far as the test goes for this, you're just going to be matching. But anyway, in the vertical asymptote, it goes to the left too. That means your vertical asymptote is at -2. So it is the vertical asymptote x equals -2. You've got this piece right here, and then you also have the tail, and it approaches the vertical asymptote, okay? So you got that piece of the graph. Domain is left and right. The farthest to the left it goes is -2, but it doesn't reach it, so it goes to infinity. To the right, and then it ranges up and down. The lowest it goes is -infinity, and the highest it goes is infinity. And then natural log, same thing. Natural log of x plus 3. This shifted to the left too, so the vertical asymptote was at -2. This one is shifting up 3, so the vertical asymptote is still going to be at 0, but we'll check that. So natural log of x. Don't put parentheses unless I tell you to. There are not parentheses around this x plus 3, which means technically the parentheses end after the x, and then plus 3. So now we go to the, well, we could look at the graph. I'm going to go zoom 6. And so you see what kind of looks like a square root, but if you go to the table, you see that the first error message is a 0. which indicates your vertical asymptote. So your vertical asymptote is at 0. So x equals 0. And then at 1, it's at 3. And then it's at 3.6 something, and then 4, basically. And then at 8, we're at 5, basically. And then 5.3. Okay. So, who are you? Oh, you're just a fault. Okay. So, we just sketch it, and then don't forget this piece. And there you go. So as far as domain and range goes, domain, it goes, the farthest to the left, it goes to 0. It doesn't reach it, goes to infinity. And range is up and down, negative infinity to infinity. Okay, properties of logarithms. They will give you the properties, and I'll show you what they'll give you in a minute. I need to expand and then evaluate, okay? It does say without using a calculator. I don't know how they're going to place that. Anyway, if two things are being multiplied, how do you separate them, guys? With addition. So log of 1,000 plus log of x. But what's the base right here, guys? 10. 1,000 is 10 to the what power? 10 to the third. So what's log base 10 of 10 to the third? So the answer is 3 plus log of x. And that's what they would expect you to match it to. On part B, when you've got division on the interior, how do you separate them? With subtraction. So minus log base 7 of x. Now log base 7 of 7 is what? 1. So 1 minus log base 7 of x would be the answer you would be finding. For the next one, natural log of e squared over 5. That's natural log of e squared minus natural log of 5. Two different ways you can think about this. You could take the natural log and e. This is log base e. They cancel each other out, or you can bring the 2 down and then simplify them out. But they do go away, and it is 2 minus the natural log of 5. For this one, we've got 2 things in the numerator. So when we split it up, we're going to have 3 different logarithms. So we're going to have log base b of x squared plus log base b of y minus log base b of z cubed, but they will never leave the power up in the power when you expand, so you got to bring the exponents down. 2 times log base b of x plus log base b of y minus 3 log base b of z, and that would be my final answer. On the last one, everything is being raised to the 100, to the square root. That doesn't make sense. Everything is underneath the square root, which means it's all being raised to the same power. I do have a bone to pick with people, though. Guys, if I asked you to expand this right here, I had a lot of people that brought the 3 down to the front. Can you guys tell me why that's wrong? The 4 and the x cubed are separate. The power of 3 is not a power of 3 for 4. It was only for the x, so it should have been log of 4 plus log of x cubed, and then bring the 3 down to the front of that piece. You have to be aware of what you're doing as far as power goes. But in this case, the square root is the power of both 100 and x, so it is log of 100x all to the 1/2 power. So I'm going to bring the 1/2 down to the front, or you could split it up. Did anyone like take the square? Oh, I'll just give you a second. Okay. Log of 100x. I would split that up and say 1/2 times log of 100 plus log of x, because there's multiplication. Can y'all tell me what log of 100 is? It's 2, because that's log base 10 of 10 squared. So if that's 10 squared, then I'm just left with 2. So I've got 1/2 times 2 plus log of x, which is just 1 plus 1/2 log x. And that would be the answer. Another way to work that, though, is that you could have, from the very beginning, because the square root of 100 is 10, you could have just said log of 10 square roots of x. And then you can see how you would do. Log of 10 plus log of the square root of x, and that would be 1. And that would be log of x to the 1/2 power, and that would just become this. So final answer right there. Sydney, would you go?